I'm going to be talking about graphing trigonometric functions. First, let's try to draw the graph of y is equal to sine of x and see what this looks like. First, let's draw our axes and give our graph a scale. This is the y-axis, this is the x-axis. Let's make this minus 2 pi, make this 2 pi, have this be 1, and this be minus 1. Now we already know some values of sine of x at different values of x, so let's plot those on this graph. Sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0, sine of pi over 2 is 1, and sine of 3 pi over 2 is minus 1. And then sine of pi over 4 is equal to sine of 3 pi over 4, which are both square root of 2 over 2, which are about here. And similarly, we have points here and here at minus square root of 2 over 2 for x equals 5 pi over 4 and x equals 7 pi over 4. Now if we connect these points smoothly, we can see what the graph looks like. And it'll do the same thing on the other side of the y-axis. As we already know, the function sine of x repeats itself after every 2 pi. Another way of saying this is that the function sine of x has a period of 2 pi. We can see this clearly on the graph. If we start at any point and we go to the right 2 pi, then we'll be at the same height on the graph. We can try this at a few other points too, but it'll always work. Another interesting property to look at about this graph is how high and low it goes. Notice that for any value of x, sine of x can only go up to 1 and no higher. Similarly, no value of sine of x can be smaller than minus 1, which is down here. If we take the difference of these two values, 1 minus minus 1 equals 2, and then we divide this by 2, then we'll get what's called the amplitude. The amplitude of a function basically says how far away its values can stray from its middle value. So we can see here, this is 1, which is the amplitude, and similarly it can go down by 1. The other trigonometric functions look similar too. If we look at y is equal to cosine of x, then it'll look something like this. And on the other side, like this. In fact, this looks exactly the same as a sine curve, except it's shifted to the left by pi over 2. Now let's look at y is equal to tangent of x. Unlike sine and cosine, tangent actually has asymptotes, where the function goes off to infinity, or minus infinity. It looks like this. And it'll continue on in both directions in the same fashion. Since tangent goes off to infinity and minus infinity around these vertical asymptotes, there actually is no maximum or minimum value. This means that tangent does not have an amplitude. It does, however, have a period. This asymptote occurs at minus pi over 2, and this one is at pi over 2. So if we take the difference of these, that tells us how long it takes for it to repeat, which is pi over 2 minus pi over 2, which equals pi. So unlike sine and cosine, tangent of x has a period of pi. Similarly, we could graph the secant, cosecant, and cotangent functions by plotting points and connecting them, and we would see that none of them have amplitudes as they all go off to infinity at asymptotes. However, secant and cosecant have a period of 2 pi, while cotangent has a period of pi.